Okay, good afternoon, everybody. I am here with the amazing Reza Rahman. Reza, how are you?
I'm good. How about you, man? You staying healthy?
Yeah, very well.
Perfect.
Okay, if you are ready, can you start?
Okay, get started. All right, yeah, let's get started. So my name is Reza Rahman. For those of you who don't know me, in my day job, I'm principal program manager for Java on Azure. So basically, I try to make sure that everything that we have on Azure is wonderful for Java developer experience. This talk is Jakarta NoSQL powered by Cosmos DB on the cloud. So there's two different aspects to this. One is Jakarta NoSQL. I'll talk about that in a second. Actually, you probably had to talk about this already from my good friend Otavio Santana. And then we'll talk about Cosmos DB, which is another important service on Azure, as I'll explain in a moment. So this particular deck is available online. So I'm going to just post a link to the deck right away. So you can take a look at the deck afterward. So there's a link to that. And basically, all of the resources that I'll be talking about is indirectly or directly or indirectly is on that slide deck. So the slide deck is a good starting point. Okay. So what is Jakarta NoSQL? Jakarta NoSQL is basically a brand new specification. It's not even 1.0 release yet. So it's still very much a little bit in shaping up. And this is a really great point to learn about it and also to get involved and help it mature into a 1.0 release and hopefully more releases after that. So what does it do? It basically fulfills an important gap that has been there in the Jakarta ecosystem for a little while. So we've had JDBC and JPA for relational databases. We really have not had anything in terms of a standard for accessing NoSQL databases yet, unless, of course, we talk about Jakarta NoSQL. So that is really what the objective is. So whatever was done for JDBC and JPA as to relational databases, Jakarta NoSQL tries to do the same thing for NoSQL databases. And hopefully I don't have to explain what the NoSQL databases are. It's been a little while now. Hopefully most of us know what that means. So the Jakarta NoSQL API is broken up into two different abstractions, and three different abstractions actually. And these three different abstractions are meant for slightly different user bases. So the first one is a communication API. So that is very similar to JDBC. So it's the lowest level API where you access a NoSQL database. Majority of the time, you as an end user probably will not be dealing with the communication API. Really, the primary purpose of the communication API is for NoSQL database implementers themselves to implement this API so that you can access it. Sort of like the relational database folks create a JDBC driver. So communication API is very similar to that. So it's basically binding the lowest level API so that Jakarta NoSQL can talk to a NoSQL database. A layer above that is a mapping or templating API, and that is very similar to JPA. So basically, you're taking a POJO, you're saying this is my domain model, and that is being mapped to a NoSQL database in the end. So that's a mapping layer. And then there's something very similar to the Entity Manager API. So Entity Manager API, as you know, is basically a CRUD API that provides the bridge between the ORM layer, the mapping layer, and the database layer. So it does all of the translation between back and forth, and it does things like create, read, update, and delete, and queries. So similar to that, Jakarta NoSQL has a set of template APIs, and we'll talk about why that it is a set of template APIs in a second also. And then finally, there's a repository API. So this is very similar to Delta Spike Data or Spring Data JPA, if you've ever worked with it. So basically, this is a very easy way of removing boilerplate code at the repository layer. And this is also baked into the Jakarta NoSQL specification. I won't be showing you an example of the repository. In fact, I won't be showing you an example of the communication API as well. If you like the repository pattern, it's definitely very nice. You can take a look at it. There's a number of samples that I'll point to later so that you can take a look at how the repository API looks like. Primarily, when I show the demo and when I dig through the code, I'll be focusing more on the middle layer, or the mapping API and the template API. Now, one of the big challenges of writing a standard like Jakarta NoSQL is that unlike relational databases, NoSQL databases are very, very varied. So they don't really have a lot in common. So you can't just have one API that will take care of everything for you. So the best way of handling some kind of abstraction for Jakarta NoSQL is actually recognizing that there's different kinds of NoSQL databases. So these are, in general, well understood families. If you do some research on them, you'll see that these are the families that are there, that are available out there. So one is key value pair. I think that we're all very familiar with this. It's very similar to JCache, if you will. So you have a key and then a value stored in the database. That's a key value pair database, and there's a number of these. Apache HBase is probably the most well understood ones of these. But things like etcd is also just a key value store in the end. Certainly things in the Java ecosystem that we've had for a little while, Infinispan, Hazelcast, and the like. These are coherence. These are really all key value stairs for key value pair data stores for the most part. Then there's column family. So this is a step above key value pair in that you can store multiple values in a columnar fashion in the value. So it still has a key, still has a value, but the value is very rich and can contain multiple columns that you can query by, for example. So there are a few of these out there as well. The most well-known of this is basically Cassandra. So this allows you the very simple storage of key value pairs, but it also allows for some querying capability because of the columnar nature of it. Then there's document databases, and literally this is just storing a key value, but the value you're storing is actually a full-scale document. So every data element in there is queryable, not just the columns, but any data element that's stored within a document. The document is usually stored as some kind of JSON variant. In case of MongoDB, it's actually BSON or binary JSON. And actually, I'll show you some example of that in a second as well to see how the data looks like. But it very much looks like essentially a JSON document. And finally, there's graph databases. So graph databases are interesting, and they follow sort of a niche area in data storage in that what you store is different nodes, right? So, and each of these different nodes actually has data correlating the relationship between them. So there's certain classes of data that is very, very useful for graph databases. But in general, they're not as well used as the other relational database taxonomies. By far, document databases are the most popular. We'll see that in a second. But graph databases, a good example of that is actually Neo4j. Okay, so other than these NoSQL features, the Jakarta NoSQL API also provides some other capabilities, and that is essentially integrating with other parts of Jakarta EE and microprofile, hopefully just Jakarta EE going forward. But basically, one of them is bean validation. So just like you can in JPA, you can annotate your bean model with bean validation annotations, and the Jakarta NoSQL API will respect those bean validation APIs. So that's a good piece of integration right there. And also externalize configuration. To configure your data sources, you need some kind of configuration mechanism, and Jakarta NoSQL essentially uses microprofile config, or rather not Jakarta NoSQL, but JNoSQL, which is the implementation of Jakarta NoSQL, the reference implementation, if you will, that has bindings with microprofile configuration. And I'll show you that in a second as to how it makes configuring these things a lot easier through that integration piece. Okay, so that is about the high-level view of what we want to talk about in terms of Jakarta NoSQL. Let's dig a little bit deeper now. So Jakarta NoSQL has excellent coverage, right? So pretty much from what I've seen, it covers almost every single well-known NoSQL database that is out there. I think really that's quite impressive. So whatever your NoSQL database is, you can use it basically through Jakarta NoSQL. And you can see just some of the more popular ones that I have listed here. So things like Oracle NoSQL, Infinispan, Hazelcast from the Java ecosystem, things like HBase, MongoDB, Cassandra, all of those, and of course we're going to talk about Azure Cosmos DB, and it's a little bit of a special case. I'll talk about that in a second why that is, but very, very wide coverage of a bunch of different NoSQL data stores. It's already built into JNoSQL again, which is the implementation for Jakarta NoSQL currently. Okay, so it's important to talk about, so there's many different bindings that I could show. And in fact, I'll show you in a moment, even with Cosmos DB, I could use different APIs. Cosmos DB is what's called a multi-model database. Right? So I'll explain to you in a second what that is. But it's important to understand the NoSQL landscape. So this is a Google trend graph, right? That you can take a look at the most popular NoSQL databases. And you can see some trends. So by far, when you talk about NoSQL, it really is MongoDB is maybe the de facto implementation, right? So it is by far way more popular than any of the others, as you can see from the graph here, and it has been for a very, very long time. There's nothing that really is challenging the MongoDB dominance when it comes to NoSQL databases. Redis is very, very popular as well, but Redis is a bit tricky because Redis can be used as a NoSQL data store, but it's also used as a cache. So you can use NoSQL. It's a key value database, essentially, but it is reasonably popular. But it's probably also popular not just because of the NoSQL case, but actually because of the caching case. The rest of them actually are not that popular in the scheme of things. So you have Apache Cassandra, HBase, Neo4j, a number of these other ones. They usually follow sort of the bottom half of this, so not as popular, right, as the rest. By far, MongoDB is a leader of the pack. And in fact, I'll be demonstrating to you the MongoDB API. It actually, in Jakarta NoSQL, it doesn't matter very much, but I'll be using the MongoDB API as my example, so to say, to show you how Jakarta NoSQL usage actually looks like for this reason, because of these graphs. You'll also notice this will come out even more in the subsequent slide that I'll show you. But NoSQL databases really are not. They have logarithmic growth, right? So they're not growing at an exponential rate. They're definitely probably not the database you want to use for simple applications. There are certain use cases where you would want to use NoSQL correctly, and basically the graph reflects that. Right? And of course, you can see a little bit of the COVID-19 impact there, things going down a little bit, and this is happening for the entire technology industry because of the general slowdown. We'll see if that downward trend is actually NoSQL becoming less popular, or whether it's just a temporary effect from COVID-19. And really what this is, it has a logarithmic, slow-growing curve, if you will. It was fast-growing for a little while. Things really are slowing down around like the 2014 time range, if you will, and things have become more stagnant after that. So it's been stagnant for about 5 years or so, actually more than about 5 years. Okay. All right, so let's compare NoSQL with relational databases. So this is from the DB Engines ranking. You can take a look at this yourself. They do a decent job. It's sort of like TOB, except for databases. And you can see what is happening here. So the big three databases really remain things like Oracle, MySQL, SQL Server, Postgres. These are the primary four databases out there, the most popular ones. And then you have MongoDB in there. So it's by far the most popular NoSQL database, right, as far as NoSQL databases go. The rest of them, again, all fall far below that, right? So you really have things like DB2 and the like, but those all fall in a lower band. So really the most popular ones are relational databases plus MongoDB. The key relational databases like Oracle, MySQL, SQL Server, Postgres. So you can use NoSQL databases, but make sure you have the right use case for it. You shouldn't be using it just frivolously. The primary use case, really, when you should consider NoSQL, is probably you either have a specialized API, where you want to use something like a columnar database, or let's say a graph database, or you have very large data volume, right? Or you have data that isn't really very relational. Those are different use cases where you would want to consider NoSQL. It's definitely not a replacement to relational databases, but it has a respectable space, right? And this is why having something like Jakarta NoSQL to fulfill those use cases is actually pretty important. Okay, so what is Azure Cosmos DB? Azure Cosmos DB, you cannot really install it on-premise. It's actually a cloud-only database. In fact, it's a cloud-only managed offering specific to Azure. Okay, so what this is that it is what's called a multimodal NoSQL database. It's globally distributed. So that means that given a piece of data, you could distribute it anywhere in the world where there's an Azure data center. As long as you created an Azure database instance, it really is globally available. It's really got a very high focus on things like availability, performance, meaning that any request that you make should have subsequent sub-second performance, right, in the millisecond level performance. So performance is very, very important. Scaling the database across the globe is a very important focus for Cosmos DB, and of course security, right? If you're putting data on the cloud, you better make sure it is there in a secure fashion. So definitely Azure Cosmos DB does all of those things, and it focuses on doing those things well. So the reason Azure Cosmos DB is a multimodal database is that it actually exposes different APIs to meet different NoSQL taxonomies, right? So it has a very basic SQL-like API, so you can treat it like a relational database if you want. A lot of people actually don't tend to do that. They only tend to do that when they have to use SQL and they need scaling. It has support for MongoDB, so it implements the MongoDB API, so that gives you the document database functionality. It implements the Cassandra API, so you have column family level functionality. Azure Cosmos DB also implements Gremlin, so that gives you Gremlin is basically a specification for accessing graph level databases. It's a language to do that. So basically, it exposes a Neo4j like graph API out of through Gremlin, and then there's a key value API that implements etsetd. Okay, so Cosmos DB really is multiple things together. It's MongoDB, etsetd, Gremlin, and Cassandra all in one, managed on Azure. So that is really what Azure Cosmos DB is about. So there is a Cosmos DB API on its own. It's not very frequently used. It's most frequently, again, used. The MongoDB API is the most popular, and then second is the Cassandra API, as you can imagine from the data that we have seen before. Okay. So all of this, I think we're done basically talking about the code. Now we're going to actually look at the code itself. This is the best way of learning Jakarta NoSQL. So all of the code that I'm going to show you right now is available on GitHub. So this is the link for it. You can basically, when you navigate my slide deck, you'll see the link for that. And when you click on it, it basically will tell you step-by-step instructions on how to set up the demo that I'm going to do next, right? So you have basically a small mini lab, right, to be able to do this work on GitHub. So feel free to take a look at that. So without further ado, let's take a look at what is going on. So here's the NoSQL database. So the first thing is you need a Cosmos DB instance. Okay, so you create that. I tend to create that in the Azure portal. I'll show you that in a second. But you need some local setup for the demo. So you need JDK8. I have that set up. I'm using Eclipse IDE. You don't have to use Eclipse. It's really just a Maven project. You could use any IDE that is Maven capable. Let's say IntelliJ or NetBeans or VS Code for Java, whatever that is. You can use it. It's not a problem. You need an Azure subscription because at the end of the day, this is the Cosmos DB is an Azure database, as I mentioned. So you will need an Azure subscription. You can get one for free for 1 year, and you can use Cosmos DB that way. And you need the code, and I have the code downloaded on my local machine. So the next step is to create the Cosmos DB, and I created it through the Azure portal. So I'll log on into the Azure portal for you. So it takes a little bit of time to create a Cosmos DB instance. It takes about half hour. So I didn't want to create it during the talk. It's going to take too long, and we're not going to be able to finish it. So I went ahead and created the Cosmos DB account a little bit beforehand. So here's my Cosmos DB instance. Hopefully you can take a look at it. It says Azure Cosmos DB account. Okay. And here's the instance for it. So I've created it beforehand. There's a URI that you can access the Cosmos DB instance. The Cosmos DB instance URL looks very much like accessing any other MongoDB API. And that's really about it here. So there's not a lot more to see. You can take a look at potentially the metrics. Okay, and you can see there's a few metrics here. I did some accessing here and there and so on. But you can also, once you have this set up, there's actually a connection strings tab. Okay, and you can connect to this as if it was any other MongoDB database. And in fact, that's what we're going to do. I'll show you that in a second. So I have Studio 3D installed. It's one of the better MongoDB browsers. So we'll go ahead and connect to this database. Okay, so I'm going to say connect, and I created the connection string beforehand. So we're just going to go ahead and connect here. And there's a little bit of data, as you can see here. There's just one a collection called order. So we'll take a look at the order connection here. And as you can see, order has two records in it, two documents in MongoDB terms. So one is the top one, and there's another one here. We can take a look at the data a little bit better by looking at the JSON view. Okay, so as you can see, there is the data, and it looks very much like JSON documents, right? So you have the ID, you have a zip, you have the order lines. This is an embedded set of documents that is within this single document. There's a city, street address, and the like. And there's our second document here, starting from line 32. Again, it has an ID, it has zip code, and all of those embedded records, including a customer. And so there's a customer record, and it's also stored as a record, right? So an embedded record in here that says order. So that is the data there. So let's shut down the data. Shut this down. Actually, we'll keep it open, so we'll see the rest of the record, the rest of the data as it comes through. So that's the database. It's already up and running. I have the code set up here, right? So it's just a Maven project. I'll walk you through the Maven, the POM file real quick to see how it looks like. So I have a couple of different dependencies. I'm using a snapshot version of Jakarta NoSQL and GeoNoSQL, so that's why I need to include this one repository. Artemis is a communication layer. So we talked about a communication layer. So in JNoSQL, it's called Artemis, and I'm using Artemis document because I'm wanting to access document databases, MongoDB in this case. Diana is a mapping layer in JNoSQL. So in this case, we're getting the MongoDB driver. So it's document database and MongoDB specifically. And I'm also including the bean validation integration here. And I'm going to run things in CDI Java SE mode, right? So I'll be running it, starting CDI actually in a unit test in this case. We're also using Hibernate validator as a bean validation integration and some other things here. And obviously, I have JUnit to include unit testing. Okay. All right. So that is the POM file that we have here. Now let's take a look at the code. We'll begin to take a look at the code here. And before we take a look at the code, I'm just going to run the database. Okay, here's my unit test. I'm going to just right-click on this and run this as a unit test. Excuse me just 1 second. Okay, apologies about that. You know how it goes. So here's our unit test. So there's a number of unit tests in here. I'll show you that each of these in a second. But let's go ahead and run the unit test. So I'll say run as unit test. Okay, so the unit test is run. It's relatively quick, as you can see. So there's 6 different unit tests. We'll see each of those in turn, but they all run successfully. So now let's begin to take a look at the unit test, and we'll see what kind of use cases you can actually accomplish using the Jakarta NoSQL API. So first and foremost, we are bootstrapping the Java SE container for Weld. So SE container.initReza.new instance that is starting up a CDI container. As you can see, it's before class, so it's starting before the unit test starts. And we are getting a single managed object document template. We'll see how document template looks like in a second from the CDI mechanism, and then we're just going ahead with that. So all of the operations that we'll do is actually through this document template interface. So we're creating first of all, we can create orders, right? So orders and customers is really the domain we are modeling here. So we're going to create a new customer, as you can see here. We're going to create a new order object. So we can set the customer. We can say that an order has a customer. The order has a description. The order has an address. As you can see, this is an embedded address object. We can add some order lines. Okay, so each order is going to have different order lines. So in this case, we're adding a machine for about $3,000, adding some shipping, and adding an installation fee. And after we're all done all of that, we're going to just say document template.insert. So very much like JPA, and this is going to insert the data into the database for us. Similarly, I have a couple of different other inserts here. You can take a look at it on your own time. But basically, at the end of the day, when I'm done the inserting, I do an assert to say template.count and instances of the order class. So I'm inserting the order in this case. So I can say that I've inserted 3 records. Find is also pretty simple here. So let's say you have an ID. So we stored up an ID, and we want to get the order corresponding to that ID. So very much like JPA ID finders. And we say document template.find, and we say that we want a class of order, and we pass in the order ID, and it gives us an optional object, okay, to represent the particular entity that we found. So it's sort of like finding a single record, and then we assert that it is actually present. Similarly, for testing queries, you have one of the nicest thing about document databases is that they actually have almost SQL-like query capabilities. So there's a very nice DSL that Jakarta NoSQL comes in. You can see a couple of examples here. So you can do a select from order and a where clause. You can give it an order where clause. In this case, the first in the first case, the where clause is total cost greater than 1,000. Okay. And we can iterate across the records as well. And we'll see an example of that when we take a look at the output of the unit test. Similarly, you can do orders with description like, so you can do a like query. I have a like query in here, and I have a join as well. So you can go into orders and order lines and description and see what matches machine. Okay, so these are all you can create very robust set of queries if you take a look at the NoSQL database, especially for things like MongoDB. Update is very simple. So in this case, we do a find on a particular order ID. We add a couple of orders, and then we simply invoke update, and it will update the record for us. And then finally remove. It's also very simple. You just give it the name of the entity, and then give it the ID, and it will remove it for you. I also have a test here to test out bean validation. I'll show you that there's bean validation annotations that are assigned here. So I'm creating a bogus order here, just creating our order ID. It doesn't have anything else on it. It doesn't have a customer. It doesn't have an address. It doesn't have order lines. And we're just hitting insert. Okay, and that's going to fail with a constraint violation exception to say, hey, it fails for all of these reasons. We'll actually see this in action. I'll execute this particular unit test, and you'll see all of the bean validation annotations in action. So that is the unit test. Let's now take a look at the entity metadata. So the first one we should take a look at is order. So first thing is you should notice all of these imports. This is all Jakarta NoSQL mapping column entity ID. So they look like JPA annotations, but they're really not JPA annotations. These are actually annotations specific to the Jakarta NoSQL API. So an order is an entity. It's actually the root level of our document in our MongoDB database. We have an ID, ID field that is long, so you mark it with the @ID annotation. You can have basically simple fields, so description and total cost are simple fields. And notice you denote them with that column, right? And that's gonna become columns in the document. And you can also specify bean validation annotations, so things like not blank, positive or 0. These are all bean validation annotations, and we're annotating these to do the custom bean validation APIs when an entity is actually manipulated into the database. You can have essentially embedded records. So in this case, you have order line. Remember how it was stored in the JSON. So this is that order line. So you have a list of order lines that is also a column. And the order line object itself is also annotated. We'll see that in a second. Similarly, you can have address and customer as fields as well. Okay, so let's take a look at the customer entity next. A customer is also going to be an entity in this case. So this is, again, it has an ID, it has a name, and that's really about it. It's a very simple entity. And you also have order line, and this is an embeddable. Okay, so just like a JPA embeddable, it's a similar concept here as well. And then each embeddable will have columns and fields as well. Right? So, and over here again, we're specifying all those nice bean relation annotations like min and positive or 0 and the like. And then the last one I want to show you is address. So address again is an embedded entity, and it's just again marked with at embeddable. So if you go back and take a look at the order entity, this is representing different kind of relationships. So this is a one-to-many relationship with order line, and it happens to be an embedded entity. This is a many-to-one relationship. So a customer can have multiple orders, and that is what this is modeling. So just like JPA model relationships here, this is a one-to-one relationship between order and address. Okay, so let's go ahead and dig in a little bit deeper into some of these APIs and show you how it looks like. So let's execute each of these one by one. So let's go back to the game store test, and I'm going to just execute the test persist, and take a look at the output from that. Run as JUnit test. Okay, and this is just one basic bit of data that was output. Okay, one test executed only. That's how I executed through Eclipse. So it's just one, the test persist method only. So if you look at the console, okay, we have some information from Jakarta NoSQL. We don't have to worry about it too much. And then we are saying that we want to test the persist. And we have saved 3 orders, so you can see that we went through the insert call 3 different times. Similarly, let's run the test find. Okay, so again, just one method that was done. Actually, you need to run all of them. Okay. So run as JUnit test because they're ordered. So we'll just take a look at each of the outputs here. Okay. So let's go take a look at the console. So we looked at the persist. Okay. So there is testing persist, save 3 orders. Then we're going to do a test find by ID, and we found the entity. This is how it looks like. Right. So it's got a ID, a description, a couple of order lines, and the like, and the address as well. So we're doing 3 different queries. So we found orders. There just one order above 1,000 lines. There's one order that ordered a pinball machine. There are 2 orders with some kind of machine in it, and the like. Right. So we can also test the update. So in that, we'll take the same ID as before, and we added 2 additional records to it. So you can take a look at this, all of this by yourself as well. And then we're finally doing a test remove. Right. So this is a testing the remove order. We deleted order with order ID 3. When we take a look at the browser, you won't see an order with order ID 3. And then we're testing the validity, right? So because I didn't specify any order, anything at all, so I just have an ID, the description is null, there's no total cost, the customer is null, order lines, there aren't any. So you're getting all of those bean validation annotations that failed, right? So you have description cannot be blank, order lines cannot be empty, the address cannot be null, customers cannot be null, and the like. Okay, so there's the bean validation integration with Jakarta NoSQL in action. Okay. All right. So now let me show you how the data looks like in a second, and then I'll show you the actual configuration of this as well. So going back here, let's now take a look at the closer look at the order, and I think it will make a bit more sense. So here's the orders. You can take a look at the table view. Okay, there's 2 different records. So number 3 does not exist. I deleted it. And we'll take a look at the JSON view. And again, this is the ID, the flat column, zip, the flat column, order lines is the embedded entity. They each have a cost, description, and line number. And then you have the address, city, state, description, state. You have a total cost, that is a calculated field, and then finally the customer. So you can see the mapping between how things look like in the Java realm and how it looks like in the MongoDB world itself. And you can actually write queries through this browser on this data as well if you wanted to. So it stores, Jakarta NoSQL is basically appropriately storing the data the way the MongoDB expects. Okay, so now let's take a look at the configuration of this. So there's a producer in here. So it's application scoped. As you can see, this is a little bit of configuration that I need to do. So I need to inject a document collection manager. Okay, this is actually part of the lower level API, lower level communication API. So I need to inject a document collection manager named Azure Game Store DB. So I think of this as a JPA entity manager factory. So I'm injecting an entity manager factory in here, and out of the entity manager factory, I create an entity, or rather an entity manager. So you create the document collection manager by just getting this, and ultimately CDI translates this document collection manager, again the entity manager factory, into an entity manager instance, namely the document template. Okay, so if you use the repository API, even this abstraction goes away, but you need just a little bit of configuration. Now, how is the document collection manager itself configured? Right, so that is actually configured through a few properties. Okay, so this is the microprofile config.properties that I'm using to actually wire up the database connection itself. So this is not Java code; it's all written in just key value property files. So there's a name of my document collection manager, again the name of the entity manager factory, if you will. There's a database I'm connecting to. So the database name is Azure Game Store DB. If you look in here, this is the name of the database, Azure Game Store DB. And then you have the URL, right? So this is very much like a JDBC connection URL. It's a really long field, and you get that again through the Azure portal. So going back to the Azure portal for a second. There's my Cosmos DB instance. And if you go to the connection strings, this is where the connection string will reside. So you just need to copy and paste this, and it's a rather long connection string, as you can see here. Other than that, you just have to specify that you want to use MongoDB. So you can say GameStoreDB.provider is org.eclipse.jNoSQL Diana MongoDB and MongoDB configuration. And that's really it in terms of the kind of configuration that you want. Similar to just we use the MongoDB configuration, you can use Jakarta NoSQL with the Cosmos DB Cassandra configuration as well, and the Gremlin configuration to do graph-based database access. Okay. All right, so that is about it in terms of the code that I want to show you right at this moment. So to wrap all of this up, we have about just a few minutes, about 5 minutes left, and we need to go into Q&A. So Jakarta NoSQL is a new standard for accessing non-relational databases, just like JPA and JDBC. This is for NoSQL database access from Jakarta applications. I showed you an example of a unit test, but you can easily use this application in a Java EE application as well. It will work the same way. Anywhere where CDI is enabled, you can use it. It's basically the same code to enable all of that code. Cosmos DB is basically a multi-module managed database on Azure. It works perfectly fine with Jakarta NoSQL. And there's a bunch of different APIs to it, MongoDB, Cassandra, and Gremlin. I showed you the MongoDB API in action. You can use these things together. They are a very powerful combination. You're getting the standard-based interface on one hand, and you're getting a very powerful planet-scale database on one of the larger cloud providers on the other hand. And if you want to get started, hopefully the demo code that I provided you today should be a good starting point that you can get started with. Okay. So I'll share a few resources with you at the very end. So Cosmos DB, if you want to learn more about it, there's two different resources for it. The first one is the azure.com page. This will give you more of a business overview of what Cosmos DB is, give you a little bit of a high-level architecture view. Then there's the Cosmos DB docs. This will go into far more details of the technology implementation. So you can feel free to take a look at that, and you'll begin to understand a lot more. There's many different configurations for example, consistency and global distribution. So you can fine-tune all of those things by looking at the Azure Cosmos DB docs. And finally, the specification itself is available on www.jnosql.org/spec. So this is actually the best place where you can learn the Jakarta NoSQL specification itself. And the implementation right now is JNoSQL. So in order to get to that, you get to jnosql.org. You'll see links to many different code samples and additional documentation, videos, and the like. So to learn more about JNoSQL as the implementation for Jakarta NoSQL. So I think that is all the time I have right at this moment. I guess let's go and do a little bit of Q&A. Let me know if you have any questions on any of this. And we have about 5 minutes for Q&A, then we need to move on into the next session. So any questions?
Okay. Yes, Reza, we have more questions.
Okay, tell me. Yeah.
This is the difference.
Went by too fast. If you can read it. Okay. When using Azure AD B2C, can we use either options for database or other user pool? So when using Azure AD B2C, this is not a question really for Cosmos DB. This is about integrating with Azure Active Directory. So Azure Active Directory provides a B2C, which is basically a JWT OAuth-based protocol. So you can use options for a database connection pool if you want. I'm pretty sure that probably if you look at the docs for that, it should tell you more details. I don't know offhand exactly what the answer is.
Okay. This is a question is about.
Yeah. So this is an interesting question, and there's no right or wrong answer to it. In all reality, when you have databases that are like just under a few gigs of data, the database is basically very relational. Normalization does not hurt. You have reasonable performance coming from a SQL database. You really would just use that. So I would say in 80 to 90% of applications, relational databases really should be the default choice. And most people know how to use this very easily. It's a very mature technology set. So when would you consider NoSQL? You would consider NoSQL in several different cases. So each of these NoSQL databases have their own strengths and weaknesses. So one very clear indication of the fact that you need to use a relational database is if you have multiple terabytes of data. Right? So you have a very large data set that just is not possible to store very well in a single database instance, because relational databases, in the end, because they have to guarantee ACID, they cannot be distributed, right? So if you have a very large, let's say, multiple gigabytes, hundreds of gigabytes or terabytes of data, that's a good use case for beginning to think about NoSQL. That's one case. Another case is when you have data that is unstructured. So you don't know beforehand how the structure of the data looks like. That is not a very good fit for the relational database model, because the relational database model expects the data to be known beforehand, right? That's what tables and columns are about. So if you don't know that, that's another use case potentially for key value stores or columnar data stores. If you don't know how ahead of time, if the data is very, very irregular, that's another good use case for NoSQL. If you're using data that is not very mission critical, right? So you just need to store the data somewhere for some period of time and process it later. That's another good use case for NoSQL databases, because you're not paying the cost of a relational database. You can just go get away with a cheaper open source database. And the last case is if you have very, very specialized data handling cases. So graph database is an example. So sometimes relational databases are really not that good in modeling relationships, right? Very, very heavy relationship-driven data. So graph databases are a good use case for that. If you're really just storing documents, right, and that is in fact what you're storing, it doesn't make any sense to store a document inside of a relational database. So again, it's a specialized use case where things like a document database would be a perfect fit. You're using caching, let's say, right? So for caching, it doesn't. You don't want to use a relational database. It's much better to use something like Redis that has a key value store. So there's all these different use cases aside from the main use case of CRUD applications where you would really want to use relational databases most of the time. But if you have all of these other cases, that's where you want to begin to think about NoSQL. Okay, any other questions?
Yeah, Reza. Cosmos
Yes.
DB offer backup policies?
Yes, it does. So there's many different grains of this. You can the link that I showed you for the Azure Cosmos DB doc. You should go look at that. It is generally vertical, not it is generally horizontal, not vertical. The entire Cosmos DB model is geared towards horizontal scaling. That's how you get these globally distributed databases. It's not vertically. So you don't add more horsepower. In fact, you cannot. You can only add additional nodes to Cosmos DB. You can beef up the hardware.
Okay, I have another question from Italo.
How does Cosmos DB service handles environments? I have a minor project and I would like to add new dev and QA environment to do that, more quality assurance. So there's a free tier in Cosmos DB. So if you have a data size under a certain size, you can use Cosmos DB for that for free. So that is perfect for dev and QA use cases. But if you go over a certain size, which you will, if you're using a NoSQL database in a production setting, most likely, you will be the free tier will not be good enough. So you can use the free tier for Cosmos DB. So you create a separate database for QA, a separate database for dev, and you can basically use a free tier for that. But when you're deploying into production, you will need to pay for Cosmos DB, and you'll need to probably pay for a production-grade distributed database.
The final question from Italo. Studio 3T is great. I use also Azure Data for SQL. Does it work for Cosmos as well?
Yes. So Studio 3. So Azure Data for SQL, I don't know for sure. I'll have to investigate that. But I use Studio 3T. I've used it for a number of years. Whenever I use MongoDB in particular, it's a browser specific to MongoDB. Because at the end of the day, Cosmos DB implements the MongoDB APIs, you can use Studio 3D perfectly well, or in fact any other browser that is specific to MongoDB, you can use it for that. Same thing for Cassandra, right? So if you're using the Cassandra API for Cosmos DB, then you can, because it implements the Cassandra API, you can connect to it with any kind of browser or tool that can speak the Cassandra protocol.
Okay. Okay. Well, no more question.
Okay.
Congratulations, Reza. This was a great session because it shows different use cases, tools, the information. No? That is good.
I'm glad you liked it.
If there are no questions, I am sure after watching the video several times, the public will contact you by Twitter or by email.
Sure, that's perfectly fine. The best way to do that, let me give you the link to that as well. So best way to do that is I have my own website. There's a contact page for that. I'm pasting the link here, and all of my contact information is available there. You can contact me in any which way you like. Other than that, Jose, really appreciate your time. Thank you for having me, and hopefully it was okay.
Thank you very much, Reza. I hope to see you in a new conference. Take care.
We hope. Yeah, we all hope it. Yeah. So anyway, good luck, and have a good rest of the afternoon.
Good luck, you too. Bye-bye.